You have calibrated your rainfall-runoff model. You have calculated performance metrics and the numbers look good. But then you plot the hydrograph and something doesn't look right. Peaks are slightly early, recession doesn't match, and Baseflow looks unrealistic. This is why visual inspection is the essential first step in model evaluation. Statistical performance metrics provide quantitative summaries, but they have important limitations. They aggregate errors into a single number. They weigh different parts of the hydrograph differently. They often lack temporal context, and in some cases they can be misleading. Visual inspection allows you to directly examine when errors occur, what type of errors dominate, and whether the model behavior is hydrologically plausible. A robust workflow should always follow this sequence. First, plot observed versus simulated hydrographs. Second, identify patterns and deficiencies. Third, test these observations using targeted metrics. And lastly, iterate model adjustments based on visual evidence. This approach ensures that you diagnose problems based on process understanding and not just statistical optimization. When visually assessing model performance, focus on key hydrological features. First, peak flow characteristics, parameters such as magnitude, timing, and shape. These indicates issues with runoff coefficient, loss parameters, routing, and lag time. Second, base flow and recession. Check whether base flow is too high or too low, and whether the recession matches the observed decay behavior. These relate to groundwater storage, recession constants, and subsurface processes. Third, volume balance. Is the simulated hydrograph consistently above or below observations? Do cumulative volumes diverge over time? This reflects systematic bias in water balance. Fourth, temporal performance. Does the model capture rising and falling limbs correctly? Are multi-peak events reproduced accurately? Errors here often point to rainfall resolution issues, soil moisture accounting, and model structure limitations. Fifth, event-to-event consistency. Check whether the performance varies by event size, season, and antecedent conditions. This reveals whether the model is robust or condition dependent. Let's go through a few examples. In our first one, we have a well-calibrated model with good performance across all flow regimes. Peak magnitude and timing are captured well, and the rising and recessing limbs are great. Total simulated volume should be very close to the observed one. In our second example, the model is calibrated primarily to flood peaks, resulting in excellent high flow performance but severe base flow overestimation. Total runoff volume is also severely overestimated. This could be fixed by adjusting the groundwater storage component or infiltration rates. In our third example, the model produces correct peak magnitude and base flow, but the peak arrives late. The overall hydrograph's shape, base flow, peak, and volume are quite close, but there is an obvious 12-hour lag. This could be related to the wrong routing parameters. In our last example, the model produces a correct total runoff volume, but underrepresents variability by a lower peak and a higher base flow. This could be related to several reasons such as routing over attenuation, too large time steps, spatial averaging, or too dominant groundwater components. Beyond hydrographs, additional plots provide deeper insight. Examples are scatter plots, residual plots, flow duration curves, and double mass curves. These tools complement hydrograph inspection and help isolate specific deficiencies. Visual assessment is not a replacement for a statistical evaluation, but it is the foundation of it. It tells you where the model fails, why it fails, and what to fix. But it also has limitations. It's subjective. It depends on the scale and interpretation, and it becomes difficult for large datasets. So, the best practice is clear. Use visual and quantitative methods together. Visual inspection identifies the problem while quantitative metrics confirm and measure it. Note that sometimes what looks good in numbers doesn't make sense in reality. If you found this video helpful, please share it with your colleagues and don't forget to subscribe for more videos like this. Thank you for watching, and I will see you in the next one.